Are there any small community biochar digesters on the market right now where like a small community could go together and invest in a small producer, or is this something that's only available to somebody with megabucks?
There aren't ones shelf ready at this point. That is a real goal of most of the technology designers and producers right now, but the problem is we're in the beta stage. And so the technology that is available, that's highly controllable and functioning well, is very expensive because it's one of their beta models at this point. However, that said, there are communities throughout the world that have created retorts. For example, there's an atom retort, and it's a 4x4x8 masonry unit with a firebox on the side. You load your materials. It holds a ton of materials at a time. You get the process started by about 50 pounds of firewood in the box on the side. Through the unique and patented draft system, you can create 500 pounds of biochar in one firing. It's very energy or labor intensive, and so we're doing a pilot program in the U.S. looking for ways to modify that kind of a design into something that a group of community garden folks or a small community could build a retort. And if you want to know more about that, I'll tell you more about the Atom Retort Pioneer Program. Guy?
Can I address that briefly?
Oh yeah, sure.
So on our property, we designed and built a biochar kiln, a small one, and it produces about 15 pounds of biochar with each use, and it uses for the biochar, for the biomass that's going into the kiln, we just use weeds. Last year's kochia is a prime example, and then for the fuel to fire it, we just gather small woody material. We light it up, and it gets up to about 550 or 600 degrees Fahrenheit in a minute and a half, and burns down, produces 15 pounds per run. We typically produce one run each day because the kiln gets so hot, it's hard to handle more than once a day. It takes one person about an hour and a half to do the whole routine, to gather it up, burn it, light it off. So it's pretty simple and straightforward. If you go to my blog, guymcpherson.com, and search on biochar kiln, it'll show you a film and probably another post where we describe it in some detail.
Yeah, thank you. There are a number of open source designs that you can make biochar units out of barrels, cans, anything from this tiny to as big a barrel as you can find. Northeast Biochar Initiative, Biochar Northeast, I think they're called now. It has a lot of really good work done in that area. They even have biochar stove making camps at the New England Small Farm Initiative. And Killian, you had a point.
The question was from one of our people online, and they're wondering in terms of using waste materials, and this would go to you, except the question is a little bit more refined, but you might have something to say about it. In terms of using waste materials, do the machines that we saw in your presentation, do they have a filtering process of taking out harmful chemicals?
No, not out of the solid wood material itself. And so you need to be pretty sure what you're putting in there. And we sort the input. Yeah, I mean, if you have woody material from a questionable source, I would not use that for biochar. So my recommendation, and would you say the same, Guy? We're having a nodding of heads here. So know your materials and start small. I mean, definitely do some tests. Not even in your soil, in your garden. Pull it out, put it in pots, test it to see how the char that you're making reacts with your soil. And that's an area right now that the International Biochar Initiative is working on, and that is some standards for biochar. Because not all biochar is created equal. It has different properties based on the feedstock and the temperature at which it's created. And so you want to make sure that the pH and the constituents in that in your biochar and the behavior, the expected behavior of that biochar matches your soil, because you're not going to get it back out very readily. So you need to know what's going in there. Typically, I find that I put biochar in my soils. I pull it out of my slash piles that I've burned over the years. You know, it's materials that are made. I mean, it's from the same materials on site, so I feel fairly comfortable with putting them, converting them to a char and putting them back in the soils there. But
based on what you just said, you could actually use biochar to alter your pH.
oh yes, very definitely. Yeah, it can be a very, very good liming agent. Unless you use an extremely high temperature up in the 650, 700 degrees centigrade range, which is typically a gasification process. So you're really looking to maximize your syngas outputs, which is fine if that's the output that you want. But the biochar that remains will have a fairly low pH. So you want to make sure you know what you're using. And pH testing is really simple. So, I'd do a pH test on your biochar too before you put it in the soil. More questions?
Actually, this came from a comment I think Stephen made over there, which I wasn't aware of. He said, I think it was you, about overloading the soil in some way with using biochar.
Well, I was thinking about the potential for creating a pH imbalance in the soil. I think you addressed that.
Mm-hmm. The research that's been done to date has gone as high as 60 tons per acre of biochar before seeing some deleterious effect. And if you're man enough to put 60 tons of biochar in an acre of soil, I'll give you food, But it's a tremendous loading. And we have been fooling around with I shouldn't say fooling around. There's a lot of scientific research going into questioning how much biochar is appropriate on a per acre basis. A colleague of mine that works at NASA has come up with a real interesting little chart where you can just plug in, I want it for a field or a container or a garden, and my soil's like this. And it's really useful for the novice because you don't need to know the chemistry of your soil necessarily, mostly its characteristics. And we've come out to on a field application, maybe 10 tons per acre would be a good value. But any amount helps, and we're pausing now and saying, biochar probably, when it was added to the soil, it was being mixed with compost. So we're very excited about the opportunities of mixing compost and biochar together before putting it in the soil, because biochar is not a fertilizer. It's a soil amendment, because unless you make it from like chicken manure, you're not going to have any nitrogen or phosphorus or other valuable nutrients in there. And so a lot of people try to charge their biochar before they put it in. They may inoculate it with mushroom spores. They might use it in as the underlayment in underneath your chicken, your straw in your chicken coop, which is really cool because then you're already mixing it with compost. Well, your chickens are in there mixing it with compost and pooping all over it, so you're charging it in many ways. Some people just put it in a bucket and take a whiz on it. It's nitrogen. It's good stuff. And so, we think that paying a lot more attention to try to recreate how biochar actually was applied historically could be a lot more intelligent way of going about it than other than just like going, let's take 5 tons and fling it on the soil. One of the problems with one of the things that we're concerned about with biochar markets is that people tend to expect miracles. I got this black fairy dust, and if I put it in my soil, my plants will grow. And, well, first of all, assuming that it's matched correctly to your soil, and you put it on, if you do not put a lot of fertilizer, hopefully organic and compost, on at the same time, you may see a decrease in plant growth for the first year or two because the biochar is sitting there going, whoa, you know, nutrients, yahoo. And so you may see almost a negative effect, and that can be very scary. But in future years, then you'll see a much more positive rebound in that. I had a really good point, but that's okay. Enough of my talking. Other questions? Guy?
If you're doing it at a small scale like we are, we use up to 10% by volume. If you're not familiar with, 10 tons per hectare, 60 tons per acre, whatever, 10% by volume, we mix down to 18 inches.
Good. That's a real good way to get it going.
In terms of what you were saying before, and this kind of touches on it also, in your presentation you mentioned the Amazon.
Mm-hmm.
And I saw a movie on that about how there are no true pristine areas we've actually been terraforming from long ago.
Mm-hmm.
Can you speak at all about how biochar with night soils, with composting as they were doing there, and what that allowed in terms of population or just in terms of sustainability there?
I don't have the actual figures. I don't remember them. There's a very good book out called 1491. And it's looking at the southern and North and South America prior to Columbus arriving, and that was no one believed the early Spanish explorers when they came back and said we went up the Amazon and there were these huge cities, and it's like, yeah, you were sampling some of the medicinal plants, obviously, because that couldn't possibly happen. But there were thousands of people in cities all along the Amazon, and it was archaeologists really that started to notice that. I mean, the Brazilians knew all about this terra preta for a long time. They didn't really know how it was formed, but it was like, oh, this special black earth, and they'd mine it and sell it for potting soil and everything else. And it was only when archaeologists started to look, it's like, wait a minute. If we go up in the air, we can see these ancient travel routes, and all along the travel routes, we have these pods of terra preta. And so piecing, one thing together after the other. And then when soil scientists came in, the earliest one was in I think, actually, I'm not even going to say because there were a couple, but when they started digging and really looking at the constituents of this terra preta, they found pottery shards and all kinds of indicators that humans had their hands in that. So, but it was I did get to go to the Amazon last fall and actually visit the terra preta sites, and for a biochar freak, it was like nirvana. And actually crawl around in that stuff and talk to the people that were farming it today, and they say, oh yeah. Our terra preta soils were, the land with terra preta 5 times more valuable than typical jungle soils. Some of the other uses of biochar which are emerging and we're playing around with, bioremediation and looking at brownfields and actually seeing if we can put biochar mats in areas that, that are polluted or toxic. We're already using it for mine reclamation in various places throughout the West. That liming effect is fantastic when you have acid mine runoff. And it also is grabbing and holding toxins. Now, the question is, do we leave it in place or not leave it in place? Well, I just met some fantastic young entrepreneurs who are creating what they call grow worms, and they have developed these fabric tubes that they stuff with biochar and use it instead of those little plastic, fossil fuel-based silt fences that are required to put up around construction sites. So instead, they use these grow worms, and they can even put seeds in them or plant trees in them. And so, when it's done catching the silt, not only does it have great silt, it has enhanced soils, and it's already got plant materials growing out of it. Another use is for vermiculite, a substitute for vermiculite. And that's really very, very important because the price of vermiculite is skyrocketing because we've exported the vermiculite business because vermiculite tends to be found in a close conjunction with asbestos. After we had the disaster in Libby, Montana, which is still an ongoing disaster with hundreds of people already dead from asbestosis who were vermiculite miners and many more still dying, it's we think that people with different color skins are more suited to getting asbestosis than us, and so we're demanding vermiculite from offshore and spending a hell of a lot of money to transport it here, not to mention the fossil fuels. And so it's a very expensive component in the nursery industry. If we can substitute biochar, especially from local waste streams, beautiful. There's a timber company in Oregon that is taking their waste materials from their mill, creating biochar with it, gaining the energy and the heat that they can, so they can dry their materials, their timber or their lumber with the heat. They can create electricity to help run their plant, and when they're done, they've got biochar, which goes into their nursery medium, and then they're growing new trees in the biochar substrate.
You just made me think, so I assume you're familiar with rocket stove mass heaters.
Yes.
Right, and they have the riser.
Uh-huh.
And they usually put something vermiculite-like-ish in between the two tubes.
Mm-hmm.
Would biochar, since it's already burned down, would that be a good...
You'd have to play with that. It may be. It depends on how hot you're going to get your interior, because you don't want to start recooking the char, because it will recook.
So it
You know.
won't cook all the way down?
Yeah, it will recook. Yeah. So and that's another thing. You want to be real careful. Yeah. On second thought, maybe we better not try that. Another really cool thing within the biochar world is, and watch for this guy, Nate McCulhey, with World Stove. A lot of folks are creating really, really cheap biochar ovens, like this big, and they're giving them to families that now cook over open fires inside their homes and huts. And the average age of a woman who cooks over an open fire is 45 years old. Children that are raised in a home in which there are open fires have a lot of respiratory diseases, and they tend to have foreshortened lifespans as well. These little stoves not only allow you about an hour's worth of heat for cooking, it's a better conversion of biomass to heat. You can use a lot smaller pieces and a lot more combinations instead of having to walk 2 or 3 miles to go pick up wood out of a forest that's being diminished because people are taking so much biomass out. And so they can cook. There's no fumes because the emissions are because of the drafting system. The emissions are sucked back in and burned, and as a result, clean air inside, less danger when you're going out to get firewood, less reduction of critical biomass in the ecosystem. And when you're done, you have biochar, you go out and you put it in your garden and you grow better and more crops. You know, it's one of those beautiful circular systems, and and that's really, I think, in anything that we endeavor to do, we really have to look at the system, and if we are mimicking nature by allowing, nothing is waste, everything is reused, or are we just keeping this linear line of trash and stuff that we put away, like there's an away. I see a 5-minute sign, which means we've got some time for more questions. Yes.
I have a really basic question. How is, you described that biochar happens at a higher temperature. How is that different than a forest fire creating char? It's not hot enough, so it doesn't create the same kind of material that enriches the soil?
That's an excellent question, and it's actually a very complex question. It's not simple at all, because what you have with a forest fire is an entire range of byproducts that are coming, that result from that fire. There's emissions, there's black carbon, particulates, greenhouse gases that are coming off of all this stored CO2. And then you have a range of materials that are left that in the biosphere, on the surface of the earth, and it ranges from ash to really really hard carbon, almost glassified if there's enough silica in the wood material, to a biochar type of carbon, real good for the soil, to ash, which has not that much value in terms of the soil. So you do have a component there, and that's nature has been making biochar and leaving it on the surface of the soil, and eventually it gets worked in. Some will obviously get washed off. So there's already kind of a biochar recycling kind of carbon sequestration that's going on as a result of fires, but there's a tremendous loss in terms of release of CO2 back into the active cycle and not sequestered in wood products, which is another reason why I say that we really have to, it's just like all biomasses should not be available for biochar. Highest and best use. If you have trees that you can make durable wood products from, that's a form of carbon sequestration. That's a very good form, and it's a very useful form. So let's not grind up that material and cook it just to make biochar, but let's take the waste from that process. So you go down the scale until you have literally waste that doesn't have higher and better uses, and make char out of that.
So from a forest management, you want to take enough scrap material out to control the forest fire potential, but not take everything out, so there is some just trees rotting into the soil and renewing the soil.
Absolutely, and this is a real scary area for people, because people are very afraid that it's somehow, if biomass to energy use is incentivized in some way, that unscrupulous people and corporations will go out and rip off as much biomass as they can. We certainly have examples of that, particularly in developing countries. So we want to avoid that. But one of the things that's been happening in U.S. and probably in all North American forests is that about 100 years ago, we unwisely determined that we should suppress all forest fires. And so by suppressing the forest fires, we've allowed a lot more biomass to grow than would normally be present in that forest. So we've gone outside the range of variability in the amount of biomass on a particular acre. There is just some research coming out of California has indicated that some forests are twice as dense, carrying twice as much biomass as they historically have before we came in and did our fire suppression policy. So there's a lot of extra biomass out there, but it's very, very important to leave enough biomass out there for all those good purposes, and it's better to leave even more than you might. Now the one exception is, for instance, I use my property as a demonstration area. It's a forest that needs restoration. It also had a lot of dead trees on it. I've removed the dead trees, but I've picked up a lot more slash than I would if it just in the wildlands. And then one more thing, because I think we've got to wrap up, is it's really important, if you're having biomass to energy discussions, do not let anybody talk you into the need or the importance to go into the wildlands or to create new roads to access biomass. There's plenty of biomass. Yeah, don't let them do that. There's plenty of biomass available right now, particularly wildland-urban interface, places that could benefit from being cleaned up or having some biomass removed from it. There's no need to go into the wilderness or backcountry and start whacking trees or cutting anything for the sake of biomass production.
Home, Albert had that little container. Is there? What is the internal? Do you buy it somewhere? Could
you can make them. What Albert was showing us was actually a world stove. Nate McCulhey. But most of Nate's work is dedicated to Haiti and Africa right now. Go online and look for TLUD. It's called Top Load Updraft System, and there's tons of plans, open source plans on the internet on how to make your own little camp stove, your own little biochar stove, again, from anything from this small up to big barrels. Lots of good videos on YouTube on biochar production. So yeah, and it's open source and everybody's real excited about it. And then biochar-us.org has some good links. We're just sort of bootstrapping the website, but it helps get you places. And if you have any questions, feel free to contact me. And we've got a great network. And Albert is also on our board of the U.S. Biochar Initiative. Actually, we have some of the best biochar heads in whole world on our board, so we're really excited and can certainly provide information.